These are some notes on the discussion board in Week 3 of Math 240 Applied Statistics. The topic in this week is called Beyond a Best Guess, Adding Precision with Confidence Intervals. It's not hard to make a best guess. We can collect some data and make a calculation. For example, we might ask 100 people what their favorite ice cream flavor is. If 25 out of the 100 say that it's chocolate, we can say we estimate that 25% of the U.S. has chocolate as their favorite ice cream flavor. In statistics, we want to go to the next level. We want to quantify how accurate that 25% is. For example, could the true number over all residents in the U.S. be 23% or 30%? Is it possible that 30% of the U.S. has chocolate as their favorite flavor, and we just happen to pick some who didn't like chocolate as much? You hear this all the time in political polls, where you might find that 25% of voters favor blah 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 with a margin of error of 4%. The margin of error quantifies how accurate the 25% estimate is. For example, if the margin of error is 4% on a 25% result, we're saying that it could reasonably be between 21 and 29%. As in the other discussion boards to date, you have two options. In this week and in the next 2 weeks, we look at very similar questions about two different types of measurements. We look at the same questions for population means and for population proportions. This week, you are to choose one of those two options. To either have an initial post on a problem concerning population means, or to have an initial post on a problem about population proportions. No matter which one you post to, you are to respond to classmates in both of them, at least one in each. The first option is for you to talk about population means. Like the other DB videos, here are some aspects that are not sufficient. Some students confuse the population mean with individual data items. You need to analyze the mean. In other words, your sentences should be, the mean value is blah blah blah, a confidence interval for the mean value is blah blah blah. You have to have a lot of sentences involving the term population mean. You should not be saying that a data value is something. We're not concerned about individual data values. You need to also talk about the accuracy. You need to combine the confidence level with an accuracy. So you need a percent confidence and you need an estimate of the accuracy. Here are some aspects for your initial post that would make it much better. Of course, we need data to compute a confidence interval. It would be very good if you specified how you got your data. Perhaps you actually designed an experiment. However, doing so requires quite a bit of work. Perhaps you just asked some friends, like the example in the DB. That would be a convenient sample, and strictly speaking, not eligible to do a confidence interval on. However, if you do a convenience sample like that, go ahead and do it, noting that you're assuming that it's all right, even though it might not be, and let's do the calculations anyways. So it would be an illustration, not strictly statistically correct, but okay. Then in your response to yourself or others, calculating the standard error is something that's very important. You should explain a little bit about how you calculated the standard error and other items such as the t-critical value. Things like that would make your post much better. If you choose to do option 2, that's on population proportions. What are some aspects that would make this insufficient? Well, a population proportion is always something out of something. 53 out of 100, 8,922 out of 17,417, things like that. So you have to have some kind of data that gives you a percent, the percent that are a success. If you're doing it on people, you'll be analyzing something like the percent of people who like chocolate ice cream, the percent of people who voted for candidate A, the percent of people who have tattoos, whatever. The second thing that you should be careful of is that there are two different percents in these confidence intervals. One is what you're measuring, the percent of people who like chocolate. The other one is the percent for the confidence, 95% confidence. It's just kind of a coincidence that there are two different numbers here that are both percents. So make sure you have them straight. One of them deals directly with the data. The other one deals with the accuracy. What are some aspects of a better post? In your initial post, you should explain where you got your data. Maybe you collected it yourself. Maybe you found it on the web. Maybe you just made it up. Whatever. Officially, in order to do a confidence interval, every observation has to be independent of the next. In other words, if you asked 500 people what their favorite ice cream flavor was, you would have to ask each one individually, separate from the rest. If you came across a group of 5 people, and the first one said, "I like chocolate," and the other one say, "Oh yeah, me too, I like chocolate too," those are likely not to be independent, and from an official statistical point of view, you cannot do a confidence interval. No matter what, go ahead and pretend that your data is okay. Go ahead and pretend that your observations are independent and do your confidence interval. In your follow-up post to your initial post, you should explain some of where you got your numbers, where you calculated your standard error, whether you used a normal or a t-distribution, things like that. In your 2 responses to classmates, again, here are some things that are not sufficient. I'm always emphasizing that a comment like "great job" is never sufficient. Not in this class, not in any class. If you do not specify a confidence interval, you haven't solved the confidence interval problem. So whatever your response is, it has to have two numbers, the lower limit and the upper limit of your confidence interval. However, a response with just those two numbers and no explanation of how you got those two numbers is not sufficient. You need to show that you understand the process of how to calculate a confidence interval. Here are some aspects that could be part of a much better comment. You could explain how you got your numbers. You can say, I calculate the mean is this, the standard deviation is that, therefore the standard error is such and such a formula, which turns out to be this number, and basically walk the person through how you did your calculations. Another thing that you could do is to do a slightly different version of the problem. So if your classmate said, calculate a 95% confidence interval, you could actually post, here's a 99% confidence interval, and this is what I did differently. Because there's basically just one calculation, one way to do the calculation, you don't want 15 people to solve the same problem. So if you want to solve a problem that others have already posted to, you might want to change the number some to show how that would work. Here are some videos available to you to help you on your homework. These are all on the YouTube channel. There are 5 problems where there are both StatCrunch and Excel solutions. The first 3 are on proportions, the last 2 are on means. In most cases, I'll first talk a little bit about the problem in general, and then we'll have 2 specific videos following it, one showing the calculations in StatCrunch and one showing the calculations in Excel. In addition, there are videos for 3 other homework problems. These do not involve any calculations in StatCrunch or Excel. These are the margin of error and 2 sample size problems. The sample size ones are perhaps the more difficult ones this week. And in addition, there's this video which talks about the discussion board.